Good morning, good day, and good evening. I'm, as always, your host, Rody Robertson, and today, with someone who you may not know the name of, but if you've been following, a lot of Linux graphic stuff, you've probably seen some of the work that he's been involved with. Welcome to the show, Karol Herbst. How are you doing?
Hi. Great. And you?
I'm doing pretty good. So I think, correct me if I'm wrong, but the best way to describe the general work you do is work on the Linux graphic stack. Is that a fair way to describe it? Or do you have another way to describe it?
Uh, yeah, I think that's fair enough. I'm more leaning to the compute side now, but it's still like I'm working on Misa primarily. So
Right. I wasn't particularly meaning specifically gaming graphics. I was sort of meaning all of that together. But I guess compute, yeah, I guess compute you would consider separate from that. That makes sense. So the three main things that people probably recognize that you've been involved with, I'm sure there are other things as well that you can definitely talk about, but the three main things that are definitely noteworthy of late, especially, are NVK, RustiCL, and Nouveau. Those are all, people are always going to be talking about them as they are being improved.
yeah, I think that's fair.
So I guess we can, before we get into any of that stuff, how about we talk about how you really got yourself into this sort of space? How did you get yourself involved in, well, not only doing the driver stuff you're doing, but sort of getting yourself involved in Linux and FOSS in the first place?
Yeah. Yeah, I think that's quite a fun story because I used to start as a Java backend developer
Oh,
doing Java
okay.
backend stuff. Like the full story with 500 lines of stack traces. Some Java developers know what I'm talking about. Um, and at some point, we never had like Windows installation in our home.
Mhm.
My father was mostly like Apple user with all the Mac stuff going on. And at some point, I just got into like HTML programming and, got some jobs with Java and stuff like this. And at some point, I was like, yeah, Linux might be something fun to try out. I remember that at some point, my father got like a Linux
Mhm.
CD installer in some Mac magazine with a penguin on it, and that was kind of my reason to wanting to try it out,
Mhm.
just because of the penguin. So uh, at this point, he was like against that idea, and I didn't have enough hardware of my own, so I
Mhm.
couldn't. But yeah, at some point, I was just having this kind of laptop with an Nvidia GPU and installed Linux on it because open source, and it kind of made sense to me.
Mhm.
Um, I think the first thing I was mostly involved is because it was a gaming laptop, playing games on Linux and everything, and it was like I think that was like 12 years ago. It was like not in a great state. Um, so the only way to reasonably game on this laptop was still like with the Nvidia driver.
Right.
And even like the hybrid GPU setup was like kind of a mess. And I had one of those laptops where you can't flip the main GPU. So yeah, I think there was this project called, I don't know if the project was called OptiRun, but there was like this command which starts like a second X server and is copying stuff around a Bumblebee was the project.
Yes,
So it
yes.
was part of Bumblebee, and yeah, so that's why that's kind of the reason how I got into Linux gaming stuff. And at this point, there was also like, I don't know if you heard of it, but there was like the Zura and the Zurium, which is like an open source client like Steam.
Okay.
I, I don't know if people are familiar with it because the company was kind of financially in a bad state, and that they had like this open source
I
version
guarantee
of
there's gonna
it,
be
and
one random person who's like, I remember that thing.
hopefully, yeah. So I started to contribute to this project.
Mhm.
Oh yeah, I see the last change is like 9 years ago. So
Okay, a little
it's
bit
an
ago
old
then.
project. But yeah, I think I don't know if I'm still the biggest contributor, but yeah, the build system was like a bunch of shell scripts. And because I knew CMake at this time, I was like, yeah, let me just port this entire mess to CMake. And yeah, so yeah, I got involved in, helping out with this open source gaming client. Um, it's, basically like Steam, just open source. So fixing bugs and all this kind of stuff.
At that time, did
And
you have any like existing programming experience, or were you learning to program like as you were doing that?
not really. I mean, I've talked about the Java and the HTML stuff.
Right, right.
I was like kind of familiar with C. I also programmed in Objective-C because, Mac system and everything.
Right, right.
But it wasn't really like in a. I never had like a FOSS project before, and I kind of just got by accident into this position of maintaining this project. So yeah.
What a fun, that's a fun way to start. That's certainly a fun way to start. With those Apple systems you were talking about, was that like pre or post Unix? Was it like before they were Unix systems, or where?
I well, the first computer I kind of had access to was even like not even a Mac, but like Atari. But I only used it for like playing games.
Right, right.
But the first Apple I had contact with was also like pre-OS X.
Okay.
Like it was 9.2 or something. But
Okay,
it was
right.
like, very close to the migration, and the hardware just couldn't handle the new operating system. But yeah, from like the first actual Mac I had my own was like, yeah, it was I think 10.3 or 10.4, somewhere around that.
When you were making that transition like into Linux, when you found this Linux CD, were you aware of what Unix was at that point, or like was it just like completely unknown to you?
I wouldn't say. I think the concept of Unix itself was unknown to me, but I was familiar with like command line stuff.
Right, right.
And
So the command
so
line
on.
like felt familiar with the two of them.
Yes.
Okay, okay. So you eventually got from there into somehow working on open source Nvidia GPU drivers.
Yes. So the reason I actually started to look into Nouveau was because there was like the open source Nvidia driver. And I was like, yeah, maybe I try that. And then it's like, oh yeah, it's pretty slow. But it had like fixed the hybrid GPU setup with, suspending the powering down. My laptop even was one of those who had an LED showing if the GPU is actually turned off or on.
Oh, okay.
So yes, so I also had like motivation to, make it work so I can power down the GPU and everything. But yeah, so the reason was the performance was kind of slow and the reclocking support was in a bad state at this time. I think it worked with DDR3 GPUs, but it was broken for GDDR5. So I figured out why it was broken in Nouveau and fixed it, and that was kind of my first big patch to the project.
Do you remember roughly when that was?
2013, I would
Oh,
say.
so it was like just after Nouveau was getting started then.
I think the project is older.
It's like
But
2011, I want to say. I don't think it's that much older than that. What does Wikipedia tell me? Let's see. I want to say it's like 20. Yeah, initial release was 2012. At least according to this, the numbers might be a bit wrong here, which is very possible.
Yeah, let me find the patch.
Okay, I wasn't expecting you to find the exact patch it was. But like, regardless, it was like fairly early on in the project, within the first couple of years.
Yeah, it might be.
Mhm.
I didn't really follow up on the history of Nouveau at this point or later, so.
Okay.
But yeah, let's see. I have the patch. Yeah, it
Okay.
was 2015,
Oh,
actually,
25th.
in
Okay.
August.
It's like 3 years
Yeah.
into the project being around then.
Yeah,
Oh.
yeah.
Oh, I was
Yeah,
gonna say I'm fairly new to Linux myself. Like, how aware were people back then of Nouveau? Like, do people like, because nowadays, you know, people when they use Nvidia cards, it's like Nouveau is mentioned as a thing that exists, but most people tend to just run the proprietary drivers because as great as like the work that's been done on Nouveau is, a lot of like the experience is just going to be better right now, and hopefully some of the other stuff that you're involved with is going to help sort of improve that experience. But how aware were people of Nouveau at that point? At least how
I
popular
think
did it
there were
seem like it
more.
was?
Yeah, I think it was more popular than before NVK show up.
Mm-hmm.
Like we had like more contributors on the OpenCL driver and everything,
Mm-hmm.
and the contributors just moved away to other projects, like working on the AMD driver or something else.
Mm-hmm.
So we kind of like before NVK emerged, the popularity I think was decreasing. I think like around when Kepler was still pretty commonly used was, I think it was pretty much used by a few people because, you know, with reclocking working, it was actually useful for some kind of gaming.
What generation was Kepler?
600.
Oh, okay. So that's a while ago now.
Yeah. Yeah, so my first, like my GPU was also Kepler, and I fixed it for that. But yeah, Kepler was kind of the generation with the best reclocking support, and it was decently fast, at least for some games. And I think that the best benchmark I had was like 80% towards the Nvidia driver for some
wow.
games.
Okay.
Yes, so it wasn't that terrible, but like other games were like at 10 or 20%, so it was.
Right. So it was very hit and miss with what actually worked well.
Yeah. Yeah, but people were like, there was a bigger community of people being interested and seeing where the project is going. And yeah. And it was just declining because, you know, also with the firmware situation, bringing up new hardware was difficult. And this happened around Maxwell, which is like with the 900 series, and all the signed firmware mess.
So what's the deal with the firmware stuff? Because I occasionally will see articles about, like, you know, firmware situation improving with Nouveau, all of this stuff. What's actually the problem here, and why is it such a big deal?
Yeah, so the big thing is that for whatever reason, Nvidia came up with their signed firmware stuff to essentially lock down certain access to the hardware from the CPU side. For example, in Maxwell, we aren't able to control the fan speed of GPUs.
Okay.
So even if we could reclock, if your fan is like still slow, it's kind of a problem.
Yeah. There's only so much wiggle room you can really have there until it starts to overheat.
Yeah, I mean the GPU has overheat protection,
sure.
And at some point, like
but you don't want to hit the
levels
overheat protection. That's the point I'm getting at.
Well, that's fine to some degree because, you know, the first level of overheat protection is just throttling the clock without cutting the voltage.
Right, but if you're overclocking, the point is sort of to raise the clock. That's the problem.
Yeah, sure. But, you know, if you run at like 1/8 the frequency, you're still cutting the power consumption
Right.
by half.
Okay, that's fair. That's fair.
And yeah, and at some point, if it's like really getting hot, then this GPU just shuts off. But yeah, it's not a great place, and you don't want to run the GPU constantly like this. And then in later generations, they also like prevented us from even changing the voltage at all. And then it's like, yeah, no point in bothering anyway. So yeah, and sadly, the firmware we were getting from Nvidia was also like customly made for the Nouveau project.
Okay.
And they never gave us the firmware for power management, and only for context switching.
Okay.
Yeah, so yeah.
So you had firmware, but it was the most minimal of minimal firmware, basically.
Yes, it was enough to, drive displays and have multiple rendering contexts on the GPU.
Right.
So, yeah.
So what's all this stuff that I'm hearing about the firmware situation getting better?
Yes, so the GSP firmware is basically a large chunk of their original driver moved to the GPU side into firmware.
Okay.
And it includes power management and display management and a lot of other stuff. It's basically a lot of the driver just moves into the firmware, into the GPU. And the main advantage we have here is that we can use the exact same firmware Nvidia is using in their driver.
Right.
Which helps us because we can basically do the same thing. And now that they also like open sourced their kernel driver, because if you move everything or a lot into the firmware, there are not really any secrets anymore. We can also like check out like how the driver interacts with the firmware and what we can do with the firmware and everything.
Because I remember when that kernel module came out, there was a lot of confusion about what it was, what it would actually do, like how, like I'm certainly someone who doesn't have a deep understanding of how Nvidia's graphic stack actually functions. So what was that kernel module and what wasn't it is also very important.
Yeah, so the kernel module is more or less a layer for the user space driver to talk with the hardware. The Nvidia driver does a lot of stuff inside the kernel, like inside user space, and the kernel driver isn't really doing that much anymore. They also have something called user space command submission, which essentially means instead of telling the kernel you have commands for the GPU, they all do it inside user space.
Okay.
And they just need a kernel driver to wire up all the stuff and make sure there's no security implications of doing so and stuff like this. So basically just making GPU resources available to user space.
Okay.
It's a little bit different than the style we usually have with all the other DRM drivers inside Linux. So but yeah, there is a huge benefit for using, user space command submission because it helps with compute, because you can submit more stuff with lower CPU overhead. But yeah, the basic idea of the driver was just to have something open source, and in the past there was also like sometimes the GPL symbol situations coming up regularly.
What's this? I don't actually know this. What do you mean?
Oh, like sometimes Nvidia wanted to use interfaces in the Linux driver, and then at some point people were like, "Oh yeah, but that's GPL only. You can't use this," and things like this happening. And so it's kind of from their perspective, it makes sense to have like an open source GPL driver, so they just don't have this problem anymore.
Okay, that makes sense. So, from the from the perspective of Nouveau, what would you want Nvidia to actually do that would really help out the project? Because obviously, AMD's got this great open source driver that, you know, every gamer uses that no one really worries about, and it's just fine. What would you want Nvidia to do differently that would make this work out a lot smoother, at least hopefully?
Yeah. Yeah, I think it will certainly help if they would dedicate more developers to the project, obviously. But I think their documentation approach could also be improving. It's I don't know if you saw it, but we have this like Nvidia has this repository on GitHub with some documentation. Well, documentation. It's mostly just header files with names for registers. But yeah, they publish some stuff there. They document how to program the 3D engine or compute engine, and for example in NVK we only make use of that. So we don't really have to reverse engineer certain commands anymore. So that's certainly helping. But there are like still gaps, and from time to time we are still asking NVIDIA for more documentation, and sometimes they're responsive and sometimes they're not. And sometimes they forget to handle some requests for months or years. So
right. Okay. So why do you think there is this discrepancy with Nvidia? Like, why? Obviously, Linux is a smaller platform, so that might just be a simple enough answer. But why do you think there is this discrepancy with how they handle their drivers on Linux as opposed to what's happening over on the AMD side and over on the Intel side as well?
Yeah, I think it's probably just a perspective of, does it actually make sense to them from a business perspective? Like, would they even get, profit out of it? I don't think NVIDIA is the company to do it like out of goodwill.
Right.
Yeah, so I think that's probably
that's definitely understandable. It'd be hard to really like get into their heads and really understand exactly why they're doing something, but yeah, I think it's probably a fair guess to just say money. Like it's a simple enough answer. So what is actually the okay, how do I say this? So what is the difference between how the AMD driver is set up and Nvidia? I don't know how much you've done on that side as well. If you, yeah. Cause
not really.
Okay, that's fair.
I mean, I didn't really get into, architectural details of all the GPU drivers.
No, that's okay. That's
not
fair.
yet, at least.
So, in the state that Nouveau is currently in, what does it do well? Like, obviously, newer cards, it struggles. I saw that laugh there. Okay, what does it not do terribly?
Okay, I think we try to make we make sure that at least you can boot to a desktop and use it. That's, I think, like the baseline the project currently tries to fulfill. Like, if some update breaks, GNOME or KDE or something, then yeah, that's a regression, and we should probably fix it as soon as possible. But if like a user comes to it and say, oh yeah, I have this 10% performance regression, and it's like, I wish we had time to look into all of this, but sadly, there are more pressing issues to deal with. And yeah, everything like display related, like if DisplayPort doesn't work, or HDMI on certain GPUs, or like regressions in general. I think we try pretty good to at least not regress the driver or deal with the issues, and at least make sure that display is working. Yeah.
But you're really sort of fighting this like really uphill battle, trying to just get something that like it's a massive undertaking to get something like this to actually work in the state that it's currently in. And the fact that it does as much as it does is already like a testament to how much work has been done by all of the people involved.
Yeah. Yeah, I think the biggest problem was just that before we started NVK, I think it would have been a fair estimation to say there were like 2 full-time developers on the entire project.
Okay, yeah, that makes sense.
So there's just so much we can actually do there.
Mm-hmm.
Yeah, and it got a lot better with NVK.
Well, I guess that leads us perfectly into NVK then.
Excuse me?
I said I guess that leads us perfectly into NVK then. We can talk about that.
Yes. So I guess we were always asking about
go.
working driver for Nouveau.
What I was going to say is, what is NVK? I think you're about to explain it anyway.
Yes, so NVK is the open source working driver for Nvidia GPUs. It's still built upon the same kernel driver.
Mm-hmm.
And I don't know if the new compiler is merged, but it also shared the compiler with the OpenCL driver for quite some time.
Mm-hmm.
Yeah, I think the new one isn't shared yet, so it doesn't matter. Yeah, but yeah, it's basically just open source working implementation. And the main idea was to start the project in a way where we are doing things right and more sustainable and everything. Yeah, like a lot of issues with the OpenGL driver. We didn't want to repeat the same mistakes there. So yeah, it actively makes use of the documentation NVIDIA is giving us. And it lives inside Mesa and makes use of the same infrastructure we have for all the other working drivers there as well.
You did mention documentation there, but I have seen some write-ups from, I think, yeah, I've seen some of the Collabora write-ups where it specifically mentions multiple times reverse engineering, reverse engineering, reverse engineering. How much documentation do you actually have from NVIDIA, and how much of it is just trying to work out how this device how this can fit together?
Yeah, or maybe I should give you a better link.
Okay.
Like this one is better. So yeah, we are getting like files like these, which especially like you see that they don't really explain anything. They are just register dumps, and
I see.
But it at least it allows us to search for terms and figure out if this specific, like where to look, basically. And sometimes it's straightforward. We just search a term and then play around with it a little bit and figure out how it works. Sometimes it's a little bit more complex, and there has been work to write a new tool to be able to reverse engineer their working driver as well, so we can also compare against whatever NVIDIA is doing, and do like the reverse engineering against their driver in case we need more information.
So when you talk about like reverse engineering a Vulkan driver, like what does reverse engineering actually mean in this context? Like what sort of work would you be doing to work that out?
Yeah, so most of the time, because we also have this Vulkan CTS repository with like thousands of tests, there are a lot of small tests which test very specific cases or parts of the working specification. And what we would do for reverse engineering is to just check what commands the NVIDIA driver sends to the GPU. And then just try to figure out what to do on our end as well.
Okay. So I'm sure that's a very long and tedious process.
It kind of depends. I
Okay.
mean, the tests are pretty small,
Mhm.
so it's not that bad.
But there's a lot of them.
But it would be, yeah, but it would be like more complicated if you try to figure out certain things they're doing in games or something.
Right.
Because of the overload of information you would be getting there.
So it's approaching like a one little command at a time, and then over time you build those up, and then you get something that passes the test and hopefully also works properly as well.
Yeah, something like in the best case, it's just one unknown command, but sometimes it can also be multiple commands. And what they also have is a macro engine on the command processor. And they can, like what they're doing is they can execute a macro and it would generate more commands for the GPU.
Right.
And that's a little bit more tricky to figure out. But yeah, there's, it always depends on the test. And sometimes there are more commands involved and sometimes not.
So when did NVK get started? Because I know it's a fairly new project.
Yeah, I think it's already like 2 years old.
Oh, wow. Wow, that has been around for a bit
Maybe
now.
not quite. One and a half year, I think. Yeah.
That's still, like, it's really impressive how far it's come along. Because I know, I remember seeing articles from the start of this year about how it can actually play a video game now, which is impressive. Very impressive, actually.
Yeah. Yeah, we actually have like on our Nouveau channel, we have users actually trying out NVK on DXVK and Proton and everything. And yeah, some games are already running. It's very slow, but
Right.
it's running. So
I'm
that's
seeing
great.
this article from Gaming on Linux that was talking about your post from the start of this year with our Talos Principle running. The screenshot has it running at 5 FPS, which is more than one. It's a lot more than one.
Yes.
So it's
Yes.
functioning. It's not. I wouldn't call that playable, but it's functioning.
Yeah. Yeah, I think this was without the GSP firmware. So it was like with the most basic clocks, which are usually quite slow on modern GPUs. Yeah, I think some users are already trying it out with GSP.
Wow,
and I think
okay.
it's already got merged upstream, like the GSP support in the firmware as well. So I think it will come in with Linux 6.7.
I remember reading a
something?
Phronix article about that. Yes, I think just a couple of days ago it was merged. 6.7 GSP. Let me see. First week Linux 6.7. Blah blah blah. Yeah, GSP should be in 6.7. So it's gonna take a while to make its way out to like the other distros, but on things like Arch, like that'll be out there fairly soon.
Yeah.
That's really
Looking
cool.
forward to it. Yeah, we don't really enable it by default on GPUs we already support.
Right.
So the first one to actually use it is Ada, and that's the 40 series.
Oh, really new? Okay.
Yeah. It can be used on Turing and Ampere, which is like 20 and 30 series, but users would have to opt in. And yeah.
Is there any reason that it's
add a kernel command line flag?
Oh, is there any reason why it's going with 40 first, not also doing those older ones?
Oh, yes. For the 40 series, we haven't gotten any firmware from Nvidia so far. So that's the only GPU you can use with GSP anyway.
Okay, right. That makes sense.
Yeah. Right. And for the previous generations, we already have firmware. And in order to not like regress users, we don't use it there yet. But we do plan to flip the switch at some point once we are more comfortable with flipping it.
So that article I saw was from like the start of this year. So I doubt you just have benchmarks sitting in front of you right now, but how much better of a state is it in than it's basically like it's like 10 months ago. Like how much better is it at this stage?
I don't know, but I think Michael said he's planning to do some benchmarks on the article. I think. Yeah, in the last section of the article. Of the DSP binary firmware blob article.
Okay, I can't. You might be having a look in a slightly different article. There's a lot of things that go up on this website. It's hard to keep track of everything.
No, I just quoted the part to you. So.
Here we go. Now, you are reading a different one than I am. Okay, that's why I can't find it. Now on to benchmarking this new Nouveau Sport with Linux 6.7 to see how much it improves the open source situation for RTX 20/30 series hardware, as well as the initial RTX 40 GPU support on Nouveau. For those on GPUs prior to RTX 20, this firmware isn't relevant, with the GSP only being introduced with RTX 20 Turing GPUs. Okay, that makes sense. So this is like...
Yeah, so...
So it's for like fairly recent GPUs. So...
Yes.
Yeah. I thought you were going to add something to that.
Yeah, I assume what you are going to ask, but I think, like, not that I think, but the generations between Kepler and Turing probably won't get any reclocking support, ever.
That makes sense.
So that's very unfortunate. But if Nvidia is not giving us any firmware for that, and we asked, then it's not going to happen.
Well, it's...
I mean, there are some people who try to figure something out, but it's really not sustainable.
Yeah. It's understandable. Like, I have similar discussions with people about, like, because I talk a lot about Wayland, and I will have people message me like, I'm on a Kepler GPU or whatever, and it doesn't, like, Wayland doesn't work great on my GPU. It's like, yes, but you also have a 10-year-old GPU. Like, at a certain point, like, Nvidia's gonna stop supporting it. Whether they should stop supporting it at the point they stop supporting it, you know, that's a whole nother discussion. But there is gonna be a cutoff point where they have to just say, this is just too old, it's not our problem anymore. And look, it is what it is, basically. It would be nice if they were going back further, but, you know.
I mean, they can always try to use Nouveau. No, I mean, I think on Kepler it would be fine because we also support the Kepler GPUs in NVK. Mm-hmm. Well, kinda. I don't think it's like at the same level as Turing, but it kind of works. Mm-hmm. It's better than nothing. But yeah, all the GPUs in between are kind of not much we can actually do about.
You can also frame it slightly differently. With 20 series being the like early cutoff point, everything going forward will not be a problem. So in a couple of years, when you buy an old 20 series card, that will support it.
Oh yeah, that's true. And those GPUs are already like 5 years old. Mm-hmm. So
is it that long already?
Yeah. The first Turing was like December or September 2018.
What the hell? Turing microarchitecture 2018. What? Yeah. Okay. Oh.
Yeah.
Yeah, okay, that was a while ago, wasn't it? Jesus. Wow, that feels like it just happened. Maybe it's because like GPUs
Yeah.
started getting like really expensive starting around then, so a lot of people just didn't upgrade, and it's been like, yeah, there's less excitement I hear about GPUs nowadays than like, because I first started getting into PCs back during Kepler, and people got like super excited every time a new generation came out, and now it's like, okay, but it costs as much as a car, so like, do I want to buy it? Probably not. Like, I'll just stick. There's a reason why I think it's the 1650 is the most popular GPU on Steam Hardware Survey.
Yeah. Yeah, and that's also supported, by the way.
Mm.
It's just weird because the 16 series is newer than 20. Just in case somebody doesn't make the connection.
Right, I forgot
It's also Turing. It's just Turing without ray tracing.
Right,
basically.
I forgot about that. What? I want to know who at Nvidia thought that naming scheme was a good idea. I really do.
Yeah, it's always been confusing.
Yeah, look, like, it's probably not going to be that long till we do another reset of the numbering. The numbers are getting a little bit too high. We're going to get back to the 100 series at some point. Give it probably a couple more generations.
I mean, they went from 3-digit, like they started with 4-digit and went to 3 and now 2. So I guess they will go with 1-digit.
Yeah, just Nvidia one of it. Look, honestly, I wouldn't. At the end of the day, it's still better naming than monitor naming. And monitor naming, I don't know what goes on there. Like, outside of the size of the screen, it's like just throw random letters at it. That's fine. Just someone will work it out.
Yeah.
So, okay, with NVK, why was something like this needed? Like, what was deficient about the current method that was being done, and that something like NVK needed to be around?
I don't think that the need was really, because the OpenGL driver wasn't that great. It just we wanted to have a Vulkan driver.
Right.
But we also think about the idea of dropping the OpenGL driver in favor of Zinc. Because it might just be faster at this point in time, because more work is done on Zinc to make it actually run fast than ever was put on the OpenGL driver, and nobody really cares about the OpenGL driver. So the performance will probably not improve there anyway. So yeah, and I think one of the big problems of the GL driver is that nobody really actually figured out why the performance is bad. There are some, like assumptions, and there are like ideas on why it's bad, but nobody actually put in the time to actually performance optimize the entire driver.
I've heard a little bit about Zinc here and there, but I imagine a lot of people listening probably have no idea what that is. So briefly explain what Zinc is.
So Zinc is an OpenGL driver inside Mesa. And instead of talking to hardware, like the Nouveau driver, it's talking to a Vulkan driver. So we have this so-called Gallium framework inside Mesa, which is just a driver abstraction layer. And the OpenGL driver is using this abstraction layer to implement functionality. And Zinc is translating this abstraction layer onto Vulkan. And is able to provide not just OpenGL, but also in theory and in practice other APIs on top of Vulkan as well.
Okay. So theoretically, if the OpenGL driver didn't suck, let's just assume that. Is there some sort of overhead of doing it through this method? Or is it like not noticeable? Like, is this obviously it makes it convenient to write it, but is it a good idea if there was more resources to do the OpenGL driver directly?
I wouldn't say so. At least not anymore. I mean, Marek from AMD spent a lot of time reducing the CPU overhead of Gallium and the DNSI driver. So I think if you really want to reduce the overhead, that's entirely possible. I think some abstractions might be not perfect, but we are also like free to change them as we go. So it's not like a fixed API we can't change. So if they're like performance problems, somebody can look into them and fix all the drivers or something. It's also not like that Gallium is actually a library. It's really just an API that driver exposes directly to the OpenGL implementation. And the OpenGL implementation mostly is just responsible for tracking the state of the OpenGL context. So if you bind a texture or something has to track this stuff. And then at some point you also have to call into the driver to draw stuff or allocate memory and this kind of stuff.
So you mentioned in there what do you got? Is that T in there? What do you got on the pot?
Yeah, it's T.
I just noticed you keep filling out. How many of those have you had?
It's not much. It's like 700 milliliter the entire.
Because I just keep seeing you like pour a bit more in there. So
yeah, I only pour like a little.
Okay. I thought you had like 3 or 4 cups.
No. It's not that bad. But yeah, I was sick like last week and my throat is still a little bit. So
that's fair. That's fair.
It helps with speaking.
Yeah, totally understandable. So you mentioned Zinc would allow you to support like other APIs. What else? You can probably see where we're trying to direct this now. What else would this let you support?
OpenCL, for example.
And
it's already merged and everything. It works. It's great. I actually have ran the OpenCL conformance test on RedV, and it's passing. So it's even feature complete and everything. It's great.
So go on.
Yeah, there's still like at some point I plan to make like an official conformance submission, but for that I need like a second driver it runs on, and it has to be an independent one. And I'm not quite sure what exactly that means, because we have various working drivers of various vendors inside Mesa, but I don't know if they are like independent enough. Yeah, so I'm also looking into making it work on Nvidia, and yeah.
That's cool. So what is OpenCL? What is the purpose of OpenCL?
Yes, OpenCL. It's actually a compute API Apple came up with.
Okay.
And this was like, now I have to do math, but I think it's like 14 years ago. It's like when the specification was released, and I think Apple looked into like how to accelerate their UI in the operating system, came up with this API, I think. I mean, I didn't really look at the history, but I think like the trademark was originally Apple and might still be, I don't know, but they started it. And the rough idea was that, we have those GPUs and it would be nice to use them for everything. And instead of, running your code on the CPU, you can also run it on the GPU. And the programming language you use for OpenCL is OpenCL C. And it's actual a C-derived standard. So it's C with a bunch of stuff on top. And yeah, the main goals were just, we want to have higher power efficiency, run stuff on a GPU, and do crazy stuff. I don't know precisely what they were using it for. But yeah, that was kind of the general idea. I think it was like in the time where like the GPU phrase term was still a thing. I don't know if you heard.
I don't think so. I just had a look. Apple still does hold the trademark to OpenCL. It does. It doesn't matter at all. Just had to check.
Yeah. There was like, I think the GPU term was like a fancy word a few years ago.
GPU. That is kind of annoying to say, isn't it? GPU. General purpose graphics processing unit is a graphics processing unit that is programmed for purposes beyond graphics processing, such as performing compute. Oh, okay. So it just means compute on a GPU, right?
Yes. So the history for that is that at some point even OpenCL got like shaders. It's kind of at this time when you didn't have this fixed function stuff where you say, okay, this triangle goes there and has this color. But the industry transitioned to shaders. And this also had like implications for the GPUs, because to run, arbitrary code, you also need like something like a CPU on the GPU instead of your fixed function graphics pipeline. And Nvidia was also like kind of big with this, where they also came up with CUDA around the time, I think even a little bit before. And what they were doing is they were looking at this and said, you know what? All the shaders we are doing, it's all the same with compute. It doesn't really matter what it is. We just have one thing for the entire thing. So since like forever, how you are programming graphics shaders or compute shaders is on the hardware, it's basically the same. So that's kind of like the rough idea of where all this can come from.
As you're saying that, I checked, and CUDA's been around since 2007. I didn't realize.
Yeah, it's a little bit older, I think.
Yeah, it's been around for a little bit.
Yeah, I think Tesla was the first GPU to support it.
Jeez, okay.
That is like 8000 series.
Right,
like
okay, it was before the numbering reset.
Yeah,
GeForce 8800. Yeah.
Yeah.
That was that's a while ago.
Yeah, so everything is quite old, and they came up with CUDA, and Apple had their own thing, and it transitions at some point to Kronos to make it cross-vendor. I don't know if that was the reason, but that's kind of what happened. Yeah,
So what is this RustiCL thing that you've been working on?
Yeah, so I started it mostly as trying to learn Rust. And because I was also like, at Red Hat, we have like those days of learning where we can, dedicate some days to just, learn whatever we want, basically.
Okay, that's cool.
And I always wanted to go into Rust, and I was like thinking, because I was also like involved with Clover, which is like the old OpenCL implementation inside Mesa, written in C++. And I'm sure there are a lot of people loving C++ and everything, but it never really was like that much by most Mesa developers. So the, a lot of people didn't really like to work with it, and I was also not a big fan of OpenCL. Not OpenCL, I meant C++.
Yep.
And so because I was involved in Clover and thought like, oh yeah, we can do like maybe a new OpenCL implementation, and we could also figure out what would it actually mean to support Rust inside Mesa, or like how would if Rust becomes like the cool new language everybody wants to use, what would be a migration path for Mesa? Because, at some point you can say, okay, we will always stick with C, but that also comes with the risk of maybe all the new developers don't want to, program in C anymore. And that's kind of bad for a project if C is all what you have. And so I was thinking, I can just spend some time figuring out how to use Rust to implement APIs inside Mesa and how all the integration would work out, like all the cargo stuff and compiling Rust code with the current build system and just how it would fit in.
Most people, when they say they're going to learn a language, they don't go and implement OpenCL for GPU. Like, that's not a normal way that most people learn how to write a language. But...
might be.
No, it's awesome that you did. Like, someone's gonna be the one who wants to do that. But so it started as like nothing. Look, were you? So you didn't start like with the intention of taking it anywhere, if I understood that correctly. Like initially.
Yeah, initially it was more like a prototype. I just wanted to figure out if it would work at all.
At what point?
And it was just, it was just fun to work on it, so I kept working on it, and that was basically the reason.
At what point did you realize that maybe it's actually a good idea?
Good question. I think when I was creating the merge request for it, probably.
I think you worked that out a bit late.
But yeah, I think it was quite some. I don't know how long I worked on it before I started to merge it. Maybe a year, maybe half a year. I think it was a year because people were kind of aware of it.
I do remember talking about it back when it was like first getting a bit of attention.
Yeah, I think I was talking about this in XDC 2022.
Okay.
The first time, maybe I think I had a lightning talk in 21 already. Just saying, okay, this is what I was doing. What do you think? And yes, yeah, I had a lightning talk on the last day of 2021 on XDC.
So it's not been that long then since like it's been like a serious thing. It's still like relatively new.
Yes, yeah, yeah, it's between 2 and 3 years. Something like that.
Jeez. Okay, so you got a lot of. It seems like a lot of the stuff you're involved in is like sort of new. Obviously, Nouveau's been around for a long time, but like both NVK and RustiCL, like these fairly new additions to the way that both compute and graphics are done on Linux.
Yes, maybe. I didn't quite get what you're trying to say.
Oh, okay, no. I was just saying, your... How would I rephrase it? I don't know how to rephrase it, actually. So, anyway, we'll move on from that. So, what sort of state was Clover in, like, beforehand? Because I know there's this open merge request on the Mesa project. I just love the title, just called Delete Clover, which is a great title, straight to the point. Yes. How usable was Clover, if at all? Was there anyone who was working on it at the time? Is there anyone working on it now?
Yes, so nobody's working on it, and Clover kind of started. I don't really know the history of why people started it, like precisely, just that people started to have an OpenCL implementation. And when it was made, it was in the time when LLVM came around. And we had this LLVM compiler for AMD GPUs. So what Clover was doing is it was very LLVM centric at the start. And it was not using any of the other compiler infrastructure we had inside Mesa. There was like the time even some Nouveau developers were thinking about moving to LLVM and to have all the GPU compilers inside LLVM. And as everybody maybe knows, is that didn't happen. So we just write our own compiler inside Mesa for every hardware. And even the Radeon SI driver is in the is probably moving to Echo, which is like the AMD backend compiler for RedV, soonish. And that was kind of a limitation of Clover, that it only worked for GPUs with an LLVM backend compiler. And that included it was basically just AMD. When I was getting involved in the project, can you still hear me?
Yeah, I can hear you. Can you hear me?
Yes. Because I'm running Discord in the Firefox tab, and now Firefox is complaining of it's not responding. So I was a little bit, what is going on?
Oh, this is great. I
can't do anything, but anyway, as long as you still hear me, I can just ignore it, I guess.
I guess, hopefully. As long as the tab doesn't crash.
Yeah, I have no idea. Anyway, yes, so when I was getting involved.
Oh, there we go. Now, now the tab's gone. I think we lost him. I wonder if he comes back. I don't want to cut this because this is amusing as it is. Oh, I think I might actually need to. Alright, we'll see what he says. It still says he's online. I don't know. Oh, there he goes. There he goes. Okay, we'll cut back to when he's back.
Okay, I'm back. How long was I gone?
No, like 2 or 3 minutes.
Oh no.
Not long after you said your tab was fine, it hadn't crashed yet, it crashed.
Yeah, no, yeah, okay. Anyway, it's working now. Yeah, the main deal with Clover was just that it required this LLVM backend compiler. And we have this near thing inside Mesa going on, which is kind of like our own compiler infrastructure. And all the other drivers are using it for Vulkan specifically. So yeah, what I was doing was for Nouveau to support Near, which was also then used for Vulkan, and make Clover be able to use it as well. I think I would be lying if I say I know exactly what's the problem with Clover. I think for me it was like just annoying and frustrating to work with it or like develop on it. So
and it just...
Doing Rust was just more fun.
How has the experience been learning Rust?
Oh, it's pretty great actually.
Yeah.
And I know that there are like a lot of people who have strong opinions on Rust telling them what to do.
Mm-hmm.
And for me, it's great. I know that, developers are making mistakes all the time. That's totally normal and totally fair.
Mm-hmm.
And when a language can help me with not making those mistakes, then it's really great. With C, you usually have this, always this risk of having some out-of-bound memory access or, use after free and stuff like this.
Mm-hmm.
And at least with the things I was doing for, here, it's mostly something I never have to bother with.
Mm-hmm.
So even if, when I'm running into like heap corruption or something like this, then it's just me using the C code incorrectly inside Rust and, having bugs in the wrappers around the C functions. Yeah, so it prevents a lot of bugs and it's really helpful with this kind of stuff.
I was occasionally
it also helps that
Go on.
It also has like a strong and big standard library, which is in C it's kind of a pain because even basic things like linked lists or something is like everybody has to write their own implementation, and having the standard library and everybody kind of agreeing on what it's there really helps with having also other developers just look at the code and saying, oh yeah, those things you should probably do differently and stuff like this.
I often see people complaining about it's not just a Rust thing, but I'll see this with like typed languages as well. People complaining about the compiler telling them they're doing something wrong. The compiler's telling you you're doing something wrong because you're probably doing something wrong. Like my favorite example of this is anytime you take a JavaScript developer and stick them in TypeScript and you have a type system that's actually there, like they get very confused because the compiler's telling them they're not allowed to like do certain things with types. Like, yes, because what you're trying to do is a bad idea, so stop doing it. And I'm sure Rust is much the same in that way, where it's like, stop doing that. Like, the compiler is complaining because that's a bad idea, so stop it.
Yeah, though I would say that Rust goes further because it also like manages ownership of values.
Yep.
And that's what tripping off a lot of programmers. And yeah, because it tells you that if multiple things own something and they have mutable access to it, you might have a different state than you expect this value to be and stuff like this. And it's like quite heavily enforced. Yeah, some people just, I mean, it's sometimes a little bit annoying because you have to write code in a way where you don't run into those issues. But I would also say that it generally leads to cleaner code anyway. Like it's easier to from thinking about the code perspective because a lot of the errors you can just page out of your brain. It don't have to think about certain issues anymore. Like in C, it's totally fine to return an address to stack memory, and maybe the compiler complains, maybe it doesn't. Yeah, stuff like this.
So as you were learning Rust, how did you go about doing so while writing this driver? Did you just like look at the documentation for Rust and just wing it, basically? Like, what was your approach?
Yeah, I think it's basically that. They have this introduction thing on the RustLang website, I think, which I looked into. It was just, basic stuff on how to write Rust code and stuff.
Yep.
Nothing really complicated. But then at some point I just say, okay, I want to write code. I'm not really a good, documentation reader. So documentation is kind of things I avoid. And like documentation in the sense of, big block of text on how to
Right,
do
right.
something. I look into the reference, if it's reference manual, I don't know, but like the actual documentation of the standard library.
Right.
That's something I usually look a lot into. They have examples there on how to use code and how to use the functions and types and everything.
Mm-hmm. So, how long do you reckon it took you to start feeling comfortable writing Rust code?
Not quite sure. I don't know if I'm comfortable yet at the level where I can say, okay, I know what I'm doing.
Sure.
But I'm comfortable enough to, just write code, and the compiler is not getting too much into my way. I think there's still like a lot I need to learn and more, write code, more idiomatic and stuff like this, but I think it's not too bad.
See, most people would have answered, I feel comfortable now. Like, you have a Rust implementation of OpenCL in the Mesa project, and you're like, I don't feel comfortable writing Rust yet.
No, I mean, or is this code like optimal enough, or is there a way to do it better and stuff like this?
Sure.
So yeah, I can write code, and that's totally fine. I wouldn't feel comfortable enough to express my opinion on how Rust code should look like.
Okay,
If
no,
that
that's
makes
fair.
more sense.
So you know enough to get what you need to get done, but you're not a Rust specialist.
Yeah, I think that's a fair summary.
So, what is the state of RustiCL at this point?
It's a good conformant OpenCL implementation on some Intel hardware. So I filed for official conformance at the beginning of this year, I think. Yeah, so it's passing like the OpenCL. There's like the conformance test suite, which a lot of tests, and I'm generally testing against that. So that is what basically works. And a lot of applications are already running, I think.
Oh, okay.
It's not, it's not enabled by default yet. Just for stupid reasons, or it was actually last year, end of last year. So kind of a year until since it's conformant. Some OpenCL code is really, really heavy, and the way we are compiling code inside Mesa is that we basically inline everything into like one huge function doing everything.
Okay.
And this can lead to, some benchmarks using like 30 gigabytes of memory or more, which is a problem. So I'm not really comfortable enough to enable any devices by default yet because of that. Because, if you start something and your system goes out of memory because of that, and it's kind of bad. But besides that, a lot of stuff is working. Recently, we also merged the support for OpenGL sharing. So there's an OpenCL implementation to import OpenGL objects into your OpenCL application. And we had a student intern working on this, and they've done a lot of great work on this. And I've mentored him to, to work on this project. And I'm very happy that we finally managed to merge it. I think it was like the internship ended like 9 or 10 months ago or something, and there was like still a lot of details to cover. And the student, like Antonio is his name, stuck around and helped out with random bugs and putting it into proper shape. So And with that, you can actually run applications like DaVinci Resolve on Mesa out of the box.
Because I know that was one of the issues with DaVinci. I think you needed to use the proprietary AMD GPU drivers to actually get anywhere with it previously.
Yeah, that might be right.
Because I know Nvidia's.
I know that
Sorry, go
on. Yeah, I think there were issues the way they were like the big problem with this GL sharing implementation is that it requires a private extension on the OpenGL side as well, and the way AMD implemented it against Mesa was kind of weird and probably not working well with Mesa, but I also haven't really tried it. I know that, debugging DaVinci Resolve is a mess because, it starts like hundreds of threads, and every time there's a bug, then I look at GDP and it's like, oh yeah, thread number 500. It's like, oh yeah, okay, fine. So it's heavily multi-threading, and a lot of bugs could trigger just by doing stuff. And I know, for example, if the video, if there's like a bug, then the video preview wouldn't show and stuff like this. It's yeah, it's a mess.
So I guess it's sort of just as extreme as trying to test out like NVK, like actually try to get NVK to work like with a game. Like if instead of doing the like individual test going through that, like actually trying to like reverse engineer like from like a full game trying to run. That I probably worded that really badly. It's a lot easier.
No, I think it makes sense.
Yeah. Okay. Good. I hope it made sense.
Yeah.
There's just a lot of stuff going on with it.
Enough. Yeah, definitely. It's a complex application. It's doing a lot of stuff.
So
yeah, and I also have like other projects running. It's really hard to find like fancy OpenCL like applications using OpenCL because it's not it's not graphical. It's not visually like a game.
Yeah.
You can impress people really easily. So, but yeah, DaVinci Resolve is definitely something people are happy to see working on more hardware and out of the box and everything.
Yeah, I've seen some people talk about using RustiCL with Darktable, but like that's like just looking at Darktable as someone who doesn't understand what Darktable is. It's just like, okay, like what am I looking at here? Like what's so special about this?
Yeah, I mean, Darktable is just like Photoshop, I would say, is a equivalent. I don't know, sorry, if it's like, or maybe more like Darkroom is, I think, or Lightroom or something. One of those, professional photo editing tools.
Yeah, Lightroom's one you're thinking of, yeah.
Yeah, I think Lightroom is the proper equivalent. Yeah, and it's basically like if you have your fancy camera and all the raw pictures you're importing there, you want to, make it look better, essentially, and you have like hundreds of filters to achieve that. And as far as I know, all those filters can also run through OpenCL. So instead of using the CPU, you can actually run it on the GPU as well. Yeah, and it usually means that the power consumption is going down. It's not necessarily faster on Intel, but instead of having your CPU going to 100%, it doesn't do that, and the GPU is maybe a little bit busy, but yeah, your laptop is heating up less. And on AMD, it's even better. Like, it's faster there than using the CPU.
Yeah, because AMD's put like they've made a big deal about their whole APU things, and they've tried to like make their GPU core like really powerful, and like that was like a big push they started doing. I think when they started doing Ryzen, that was where they made that shift.
Yeah, it might be.
Like it's really cool that something like DaVinci actually works. Like that's just cool.
Yeah, I would like to share a video, but don't think it's a good idea because I used material in this, like raw video materials being copyrighted and everything, and I would have to ask permission.
Yeah, no, don't show anything that could be a problem for you.
Yeah, so, but yeah, yeah, it works. I had to fix a few bugs, but yeah, it's. I think with like Mesa 24, it should be working.
What's the current version now?
At 23.3. So
Okay.
at some point next year.
Oh, okay. So not that long away then.
Yeah.
That's yeah, that's just really cool. Let's see, where can we go from here? So I actually don't know. I don't know where we can go from here. I did ask people like in my like channel about like anything they have to ask you. So let's see what they have. Let's see if there's any questions that actually make sense in here. Anything we didn't already cover in here. Of course, we got questions about GSP. Please ask him if there are any plans for... I'm just going to read the question. If the question makes absolutely no sense, we'll just move past it.
That's fair.
Please ask him if there are any plans for SYCL. Is that supposed to be... Is that... Oh, camera's back.
Yeah, I didn't notice I haven't enabled it.
No, that's all good. Oh, now the camera's in the wrong order. Okay, that's fine.
Oh no, I messed it up.
It's fine. Please ask if there are any plans for SYCL on RustiCL, and when does he see Nouveau plus RustiCL becoming a viable alternative to CUDA? Jeez, that's a...
Can you quote? Can you post?
Yeah, I will just post the comment. I don't know if like maybe there was like a misspelling in there or something. Or if that's...
cycle.
Oh, cycle. Okay.
I think it's pronounced cycle.
Okay, I've never actually heard of that.
Yes, so cycle is a fun story. I can definitely talk about it for quite some minutes. It will also go into like compute ecosystem madness.
That's fine. I don't know much about compute.
Yeah, so the big advantage we have with CUDA is, yeah, maybe I start with OpenCL. So OpenCL has the host code, application code you are writing inside C, and then it has the OpenCL C kernel language, which you write in a separate file, and it's a different syntax and everything. So at runtime, you kind of have to load the file and into a memory buffer, and then compile your code from there and stuff like this. So it's not that great. CUDA, on the other hand, you put the GPU code and the CPU code inside the same file. You compile it with one tool, and then you're good to go. Like you call the GPU functions in a special way, but the compiler is making sure that it all runs on the GPU. So people kind of like this model more, and people came up with Cycle, which is kind of the same thing, just open source and not Cycle is just an API. But we have open source implementations, and it's kind of there to be, open C++ focused, which CUDA I think also is. And you basically write the same code for the GPU and the CPU in the same file. They use template for some of the magic. They compile now it's into implementation detail. So the problem with Cycle is that it's an API defined. It's not like the application API is defined, but not the runtime. So you don't have any actual runtime with Cycle. You have it with OpenCL, you have it with OpenGL or Vulkan. So if you compile against OpenGL, you can run it on every driver. That's not the case with Cycle. There are Cycle implementations like the Intel one, which is able to layer it on top of OpenCL. And in order to do so, it compiles the GPU code into SPIR-V. SPIR-V is just some abstract intermediate representation for GPU code. It's, like assembly, but not like this. And it's also used in Vulkan. So for everybody who doesn't know what Spivy is. And the problem is that there are bugs inside the Intel implementation which actually violate the OpenCL and Spivy specification. So the question is always, do we think, from a MESA perspective, is it important enough to work around those bugs or not? Or, file the bugs and hope they fix it? I have a merge request, which I hope I can merge soonish, which kind of makes sure the basic works. The biggest problem is that there's this optional API in OpenCL to accept Spivy instead of OpenCLC. And I actually validate the Spivy. And the validator is just screaming at whatever I'm getting from Cycle and says no. So I had to add a debug option to say, okay, I ignore what the validator is saying. And this can lead to crashes. It might not. Some stuff works as far as I know. But yeah, having to deal with invalid Spivy is always it's difficult because you also don't want to make your code way more complex just to accept buggy code for something which isn't really heavily used as much yet. Yeah. But yeah, it's like I work on this and I kind of want to make it work, but there are challenges and everything. So yeah, I think that answers the question.
Oh yeah, the second
become
part.
viable alternative to CUDA. Good question. I don't know, honestly. I know that Nvidia has a very good compiler, and I know that in MESA we would have to add a lot more optimization to match the performance of Nvidia. I think NVK is probably a better approach to get closer because Faith was also starting a new backend compiler for Nouveau. And that will be critical to match NVIDIA's performance there. And once the compiler is in proper shape and compiles code is able to compile to quick code, I was also thinking about using it for OpenCL. If it would match, if OpenCL would be able to match the performance of CUDA, I don't know. Honestly, so we have to see. But I think it's good if we would have other alternatives besides CUDA in the compute ecosystem, because everything else is kind of weird.
Well,
the biggest advantage you have with CUDA is that you install it on your system. It doesn't matter what NVIDIA GPU you have, it runs.
Right.
You don't have it with ROCm, which is an AMD's clone of CUDA. They call it HIP, which is kind of the same API, just renamed and a little bit changed. But what their difference is that, for example, in CUDA you have PTX, which is like Spivy. It's not targeting a specific GPU. So if you compile your CUDA code, you can run it on every GPU. And on ROCm, that's not the case, because they compile to GPU code directly. So if you have newer GPUs with a new ISA on the shader processors, it doesn't run. So you have to recompile the code. This is totally fine if you think in the HPC mindset, where you know what hardware you're targeting and you want to get the most performance out of this hardware as possible. But from a developer, I only have a desktop, laptop kind of situation, it kind of sucks. And they have to improve on this. And the same is also like with Cycle. They also are more driven from the HPC mindset, but they are improving. They are currently working on adding common infrastructure code to LLVM. So it's less of a problem there. And I think there are also people working on the runtime API, but I don't know. There might be rumors, there might not be. I never talked to anybody actually knowing anything there. But yeah, once this problem is solved, at least Cycle might be a good alternative. But so far, I think at least for the things I care about, and that's both the non-HPC stuff, it's more like desktop stuff where DaVinci Resolve and this kind of stuff. Then besides CUDA, you only really have OpenCL. And even if it's not like a alternative in terms of performance, it's the only alternative you have to actually have cross-vendor GPU compute support.
Right. When I was saying a viable alternative, I don't think it necessarily means, one-to-one sort of performance, but having something that actually, works. Is actually, it probably won't be you're not going to see, giant GPU farms switching from Nvidia to, AMD or whatever, switching to OpenCL, but, actually having something that's, usable, I think is definitely a good goal to have.
Yes, and I would say it is at this level. I think OpenCL had kind of a sad story a few years ago where nobody really cared about it. But I, for example, participate in the OpenCL working group at Kronos. And there's active engagement there on, improving the language and everything. So I think there is more interest in OpenCL than it was a few years ago. And it's definitely going up than going down. So, yeah. I mean, yeah, Intel is investing into it and some other vendors, so.
Okay. This is a giant paragraph, but I'm going to assume person makes sense. Okay. This might be a very harsh question, but I'd like to ask about visions of OpenCL. Currently, CUDA is very dominant on a GPU market space, which is Nvidia specific. And those trying to support AMD GPU usually fall towards HIP from ROCm instead of OpenCL. Blender dropped OpenCL backend for cycles in favor of HIP. TensorFlow only supports CUDA. And only way to run with AMD GPU is unofficial ROCm fork, which runs with HIP. Where would OpenCL stand in these situations, especially when Kronos released Vulkan to kill both OpenGL and OpenCL at the same time?
I think it makes sense for some projects to drop OpenCL support if they are not willing to spend time on it. I don't actually know what was the reason for Blender, but I wouldn't be surprised if they looked at it and said, okay, nobody actually cares about the code. And that's just, that happens and that's totally fine. TensorFlow doesn't only support CUDA. There is, I mean, it's not nice, it's not easy to run it with something else.
Sure.
But yeah, there is ROCm stuff going on, as the question stated. But there's also other projects to make it run on other hardware. There is the OpenVino project Intel is working on, which is kind of making a common API for AI ML use cases. And it claims to support TensorFlow. I haven't tried it out yet, but I'm kind of interested in looking into OpenVino because the GPU backend actually uses OpenCL. And that's something I'm planning to look into. It's very Intel specific. It uses a bunch of Intel OpenCL extensions. I don't know yet how difficult it would be to support, but there are a few projects, at least from Intel, where they are working on making it, making all the AI ML stuff usable besides CUDA. They also have their own, replacement for OpenCL called Level 0, which is just, more low level than OpenCL, and they have their own OpenCL on top of level 0 implementation, but it's for most people they can ignore this for now. But yeah, they use OpenCL for quite a lot of stuff. I wouldn't say that Kronos released Vulkan to kill both OpenGL and OpenCL. For a lot of the premise of Vulkan was always to be as low level as possible.
Mm-hmm.
And if you're an application developer who just want to get stuff done, then using Vulkan is usually not quite right. Like, I wouldn't be surprised if most, for example, indie game developers are still targeting OpenGL just because it's easier. I also haven't asked what's the general opinion, but generally, if you look at Vulkan examples and if you want to draw a triangle, then there's like this amount of code and everything. So it's not easy to use. And generally, what people use are like engines on top of Vulkan.
Right.
OpenCL is also able to be layered on top of Vulkan. So I mean, I've talked about it earlier with Zinc. You can implement OpenCL, like run OpenCL applications on top of any Vulkan implementation in theory. And Vulkan is adding extensions to make it easier to do so. Mm-hmm. So I'm making use of a bunch of very OpenCL specific Vulkan extensions, because otherwise it would be like low performance. You would have to work around certain things inside Vulkan, which is just killing your performance. So yeah, I think OpenCL is pretty straightforward to use. It's really easy to offload stuff onto the GPU with it, and I think it will stay around with OpenGL for quite a while, exactly for this purpose. I think it has more, like OpenCL will probably stay around for longer, but I also wouldn't be surprised if we end up with a new API at some point. Mm-hmm. So, but it also doesn't really matter. Because most of the work in OpenCL is really done on the compiler side, and that can be also used for any other new compute API emerging.
I was curious how much code it actually would take to make a triangle in Vulkan, so I had to look it up, and there is a lot of code there. I see what you mean. There's this page that does like a big walkthrough of the code you would need, and it's like I just keep scrolling. It's just a blue triangle.
Yeah, it's very explicit. Mm-hmm. It's very explicit with everything. Mm-hmm.
Yeah. It's explicit because it's such a low level way to interact with the GPU.
Yes. So the big problem with OpenGL was that all the memory allocation was hidden. So you could allocate like high level API objects, but you couldn't like say, "Oh, give me 500 megabytes of GPU memory."
Right.
And Vulkan is more like this, where you say, "Okay, give me this memory, and I want to do this and this and that with it, and I want to, explicit synchronize all these stuff, and there's a lot of low level stuff you have to do."
Mm-hmm. And I guess that explains why you can build something like Zinc that then does these other APIs on top of Vulkan. Because it's so low level, it gives you that control that allows you to do these more, I guess, specialized APIs.
Yes. I mean, I also done some benchmarks with Zinc, and for example, there's this LuxMark ray tracing benchmark, so a few people might know. And when I was testing on my Nvidia GPU, like it was Nvidia OpenCL versus Zinc plus Nvidia Vulkan. It ran at like 92% of the performance of the native OpenCL driver. So you have like 8% of performance loss. Mm-hmm. It isn't really runtime heavy, so it's really just executing a lot of GPU code. Mm-hmm. But it's a great benchmarks on how well the GPU compiler works. Mm-hmm. And I think 8% isn't that much of a deal.
Nope. It's probably like, at like the extremes, probably a massive deal, but like for like just having it like actually do the thing, like that's not that much.
Yeah. Yeah.
What else? Okay, let's see what else we have in here. I think we sort of touched on this before, but it's worth mentioning again. Is there any hope for Pascal and Maxwell, or are they doomed forever without reclocking support?
So I would say Pascal is doomed because we can't control the voltage.
Mhm.
Maxwell is in this weird state that because we can't control fans, like only fans, that's not a problem on all GPUs.
Mhm.
You might have a passive GPU, like passively cooled,
Fair point.
or you might have a GPU in a laptop where usually the system firmware is responsible of driving the GPU fans. Like most laptops just have one cooling system, but some laptops have two fans for the CPU and the GPU.
Mhm.
And in this case, we could actually reclock the GPU, but the firmware situation is a little bit weird because we are using the firmware of Nvidia for some stuff and making use of our own firmware for, like, we need it for memory reclocking because that's kind of a pain. Somebody would have to make that stuff work again. I had a really, really dirty hack to make it work, but apparently it doesn't work anymore. So,
And
yeah.
considering the age of the hardware, it's like not a focus. If some
So
crazy
if
person,
somebody really wants,
yeah.
So there's hope, but also not for every user of that hardware.
Right. It wouldn't hold my breath for it. But if someone wants to do it, like, there's a spot open for you.
Yeah, it would probably also be a pain to maintain, so it's kind of
Okay, that's fair.
probably with an opt-in, it might be fine, but yeah.
Simple question. I don't know what they're trying to ask. What's with the 600 GPU series? I don't know what.
It's probably Kepler.
Yeah, that's Kepler. I'm not sure what they're trying to ask.
I mean, we have a clock code. It's not perfect, but it runs, and it's supported with NVK. So,
yeah,
that
was the entire question. Here we go. Copy this one. As far as I know, Nouveau targets 535 GSP, but 545 is now certified for G4 series. I wonder how can FOSS people handle Nvidia's ABI, or if it'll ever get stable / non-breaking to stick with, or the upgrade path.
Yeah, painful question. Less painful for us. But yeah, there's not strictly a need to update to every version. There have been situations in the past where we needed updated firmware for existing generations of GPUs. Like for Turing GPUs, we had this problem that the firmware we initially got from Nvidia didn't work on newer GPUs.
Okay.
So they had to give us an update. It took a while and landed at some point. But yeah, this can arise. And because there is no stable API, it might break. I think the API at least is stable because they have like an RPC mechanism to, call into firmware code and stuff. So I think this part is relatively stable. But yeah, the entire API you would use, it's like it can change at any moment. It even changes within the release branch. So the new 535 update also broke the API. The problem with this is, I think some articles already covered it, but the firmware is huge. And just the two files we have now are like 60 megabyte. And if you consider that some distributions are putting those files into their init RAMFS, and you have like, I don't know, if you have 3 kernels, you have like the files 3 times there, it's like 200 megabytes. And if you would, update to every firmware version, we also have to keep the old firmware files because of kernel not regress user space kind of rules. So it would people would run out of space on their boot partition because some distributions are still like having this 1 GB boot partition, and it's like pain. The big problem is if you have like full disk encryption, you can't really access the file system yet. So it kind of makes sense to have the firmware inside your boot partition. And what's the usual discussion on this is, why aren't you just loading the GPU driver later? The problem with that is that sometimes you need the GPU driver to drive all your displays. Usually on a laptop, it's not a problem. Usually on a desktop with like single display, it's also not a problem because the firmware will set up your display just fine. But for example, imagine you have like an office at home and then you have your laptop like always closed. It's buried under a lot of stuff and you don't want to get it out ever and have external displays connected. And sometimes the firmware is not able to bring up those displays. So you need a native GPU driver to, bring up all the displays on your system. This usually happens if you have like multiple GPUs in your laptop. So the internal one works, but the discrete ones doesn't. Or I think it also doesn't work through Thunderbolt. I have this problem with my laptop. So the Thunderbolt, like DisplayPort MST connected display, doesn't boot up through the firmware. So it needs a GPU driver to actually bring up the display. So it's a really hard issue to solve. And if we keep adding more firmware files, then the boot partition is just out of space. So yeah, this is kind of the problem we have with this firmware, and distributions also need to figure out what to do with it.
So
and,
you mentioned
if we would update.
Yeah.
Yeah.
I was gonna bring up the boot partition.
Yeah.
I don't know what other distros do, but if you go to the Arch Linux wiki, it recommends at least 300 megabytes for your boot partition.
Yeah, it's enough for one kernel. I mean, Arch Linux also only has one kernel installed, so they don't really have that issue.
Yeah.
Like distributions like Fedora, they keep 3 kernels. I think Ubuntu is kind of doing the same, or at least like the current, like Ubuntu, I think always keeps the current one and then 1 or 2 new ones or something like this. So it kind of depends, and yeah, it's not so bad yet with 60 megabytes. But if we would update to every single firmware version, then it's not really sustainable.
Right.
There are ideas on improving the situation. Like there are ideas of having a separate init.rumfs shared across all kernels where you could, put all the firmware files so you wouldn't have to duplicate them. There are also like idea, David Early is working on it, to declare on the kernel module level what are the sets of files you need, like versioned sets of files. And you could say, I support those 10 sets, but I only need one of those. And you could then in your init.rumfs generator just pick the newest or something. This would probably also solve a big chunk of this problem.
Well, you could not have 1 gigabyte in it. Boot partition.
Yeah, but I mean, Btrfs sub-volumes would also solve this problem. So.
Yeah, but then you got to get people to stop using ext4.
Sure. I'm just saying that it's one solution to the problem.
It's certainly a solution, yeah. Let's see, was there another one that we haven't really addressed in here? I want to know how the progress with RustiCL profiles are going.
Profiles. I suspect they mean the OpenCL profiles because you have like embedded profile and full profile, which is kind of to differentiate between embedded devices and like proper GPUs. And on Intel, the full profile is supported. On AMD, the embedded profile is supported. The reason is very stupid. You need a certain amount of samplers supported, or images, or whatever, and the Radeon SI driver limits to 32, and opens like the full profile requires 128.
Mm-hmm.
That's like the difference between the embedded and the full profile isn't even that huge. It's just mostly some precision stuff, and yeah, it highly depends on the actual Mesa driver, what gets advertised. But yeah, the profiles are supported, and the code detects on what's valid to advertise. So
I think we've addressed pretty much everything then. Yeah, let me just check. Did anyone mention anything over on my Mastodon? I think I might have saw one here. Where is the replies? Why? Why is that? Okay. I would like to know what their reaction was when the Nvidia drivers leaked. I know they can't legally look at them, but did they?
what a question. No, but I seriously haven't looked at it.
Yeah,
So.
no, definitely not. Definitely don't. Also, what is their major hurdle? Having to reverse engineer stuff, DRM. What a mess of a question. I think we talked about like what the major hurdles were with driver support earlier. Like it's documentation and then having to reverse engineer stuff. I don't think there was anything.
Yeah.
Is there anything else you would like to add to that, or?
No, I think that one problem is that how the driver works can change, and then all the tools you have stop working. So that's why we have Mary work on a new tool to dump the GPU commands. But yeah, it's something you have to do from time to time, and then. But yeah, just figuring this stuff out is the biggest problem.
Well, I think we're pretty much done here then. Thank you for doing this. Appreciate it. I still don't understand much about the GPU stuff and compute stuff, but I feel like I'm more informed.
Yeah, I mean, in the end, it's just code on a GPU.
Yeah, fair enough. Is there anywhere that you would like to direct people to? Any, I don't know, talks that you've done or anything like that, or just like nothing?
Oh, I usually always have a talk at XTC. They can probably look at this, but yeah, I don't have a blog. I'm pretty bad with this. I have a account on Mastodon, so people can follow me there if they want to. But yeah, I'm
fair
posting
enough.
regularly enough, I think.
Sounds like you're busy enough doing actual important stuff that you don't need to spend your time writing a blog.
I don't think that's the reason. I'm just.
I'm trying to give you an excuse.
I'm not a very. Yeah, I'm super busy. That must be it.
I'm sure if you sat down and wrote a blog, there's definitely a lot of stuff you talk about. It's just a matter of, do you feel like actually writing it down?
Yeah.
So
no, I usually talk about the stuff on my Mastodon account. So
yeah, well that does the job anyway, and then you just post something on Mastodon, and then you get a bunch of articles written about it, and then you can do the work for you.
Yeah, basically that's kind of works pretty reliably. So.
Well, awesome. Thank you for doing this. I guess I'll do my outro, and then we'll just sign off. So go check out the main channel. I do Linux videos there 6 days a week. Not a clue it'll be out when this comes out. This will be out in a couple of weeks at this point. I've got the gaming channel that is Brody on Games. Right now, I'm probably still playing through Armored Core 6 and probably still Kingdom Hearts Dream Drop Distance. That I do twice a week on Thursday and Friday. Check out the Discord and you'll see when that all goes up. Or just check when the previous streams went up and there'll be a notification. If you're listening to the audio version of this, you can find the video version on YouTube at Tech Over Tea. And if you're watching the video and you want to hear the audio version, there is an RSS feed. It's on pretty much every audio podcast platform. You'll find it pretty easily. Yeah. So give me a final word. What do you want to say? How do you want to sign off the show?
Try out everything what I'm doing and please report bugs.
Absolutely. See you guys later.